Okay, so let's continue with this one. Okay. Let's see. Okay. So we have some of the forces in the x direction, and then some of the forces in the y. And we ended here when we were looking at the y. We had the normal, or well, I don't know if it's a normal force. We have 9 newtons going up. We had 7.5 going down, and then we had the force in the y direction, and that one was going down, so we have minus that. So I added the force of the y to the other side. I did 9 minus 7.5. I should put my units on there. These are newtons. And that's going to be force in the y. Now, reminder, if I'm solving for the force of the y, then that's going to be opposite over hypotenuse, or the hypotenuse is going, hypotenuse sine f over y. Sorry, I want to make sure I'm being clear on this. If I want to solve for f over y, well, I can say that the sine of theta is equal to opposite, which is f over y, divided by the hypotenuse, which is f, whatever that is, whatever that force is. So if I want to solve for f of y, I'm going to multiply both sides by that hypotenuse, by f. So f sub y is equal to that force, f sine theta. Okay, and so that's why I put that in there, where the sine was 45, because that told us it was 45 degrees, but we don't know what f is. Okay? Right, so if I take 1.5 newtons and I divide it by sine 45, that will tell me what f is. 1.5 divided by the sine of 45. Okay, so that is 2.1 newtons. Okay, nice. So we figured out one of our unknowns. F is equal to 2.1 newtons. Now let's look at the x direction. T, we're not sure what it is, but what can we do with f sub x? So we have T1 minus f sub x. But what if we add that to the other side? So it would be T1 is equal to f sub x, or T1 is equal to f cosine theta, right? Because it's adjacent, f sub x is adjacent. And so then I would, to solve for that, I would use the hypotenuse f multiplied by the cosine of theta. Okay? So T sub 1, well, f was equal to 2.1 newtons cosine 45. So 2.1 times by the cosine of 45. 1.5 newtons. Okay, nice. So we just solved for our two unknowns. We figured out what f was, and we figured out what T1 was. All right, now we have example number 3. Oops. See if that helps with our focus here. We'll just have to work with it on this one. Find the value of the unknown force. These are static problems, so assume that the sum of the forces is 0. Okay, so we're going to find the value of the unknown force, or forces, really, because we have two of them, right? We have an F force again that we don't know, and a T1 force that we don't know. This is not a force, it just shows us that we're 60 degrees, okay? I'm going to change that to like a 60 decimal, so we have 2 sig figs there. All right, so let's look at the sum of the forces in the x direction and the sum of the forces in the y direction. Okay. Now remember, this F can be broken up because it's on an angle. So we can break that up to F in the Y and F in the X, right? And so in the X direction, my forces are F sub X, positive, minus this 30 newtons. And those are the only forces in the X direction. So F sub X is going to equal 30 newtons. Okay. Now, reminder, F sub X is the same thing as, let's see, X is adjacent to this angle, so F cosine 60 degrees. That's going to equal 30 newtons. So if I want to solve for that force here, the hypotenuse, I'm just going to say F is equal to 30 newtons divided by the cosine of 60. Okay? So when I plug that in, 30 divided by the cosine of 60, and I get 60 newtons. Okay? All right, nice. There's our first one. Here's F. It's equal to 60 newtons. Okay? So now let's look in the Y direction to figure out this T1. So here, let's see, in the Y we have a positive force in the Y, and then we have a negative T1, and those are the only forces in the Y direction. Okay? That's going to equal 0. So we can add that to the other side, so F sub Y is equal to T1, and we know that F sub Y is F, and then its opposite, so sine of 60. That's going to equal T1, and F was 60 newtons, so if we go 60 sine 60, that's going to equal T1. 60 times by the sine of 60, that is equal to 52 newtons. Okay, so there's my F unknown, and then there's my T unknown. Now here's what's important to remember with these. If we have two unknowns, then you're going to need two equations, and you're going to solve for one of them here, and then you can plug it in over there. And then luckily, when we've been solving here, we had each of these components. We knew all of that. Yeah. All right. Practice finding the value of the unknown forces. These static problems, so assume that the sum of the forces is equal to 0. Okay, let's see, where are we at with time? Yeah, let's keep going on to this one. Okay, I wonder if I can get it to focus a little bit better. Yeah, I think that's better. Yeah, that's a little bit better. Okay, so find the value of the unknown forces. We have a T1 and a T2. And that's where we don't know how much T1 is and we don't know how much T2 is. We have 30 degrees and 60 degrees. And then we're being pulled down 30 newtons. Let's put decimals so we have 2 sig figs for each of those, okay? Okay. Now, this one is a little bit more complicated just in the way that we had to finalize what we're looking for. So maybe take a moment, just watch me go through this process, and then go back in and watch it a second time and fill out your notes, okay? So we want to know, we're going to look at the sum of the forces in the X direction as well as the sum of the forces in the Y direction. It's static, so that's how we know that they're equal to 0. T1 is going to have a T1 in the Y and a T1 in the X, and T2 is going to have a T2 in the Y and a T2 in the X. Okay? So in the X direction, I have T1 in the x, and it's a positive force. And then I have a negative T2 in the x. Okay. There are no other forces acting in the x direction, so that's going to equal 0. Okay. Now, I don't know what either of those are yet, but I can set them equal to each other. I can say T1 in the x direction is going to equal T2 in the x direction. Okay. We'll come back to that. Let's look at y. In the y direction, we have T1 in the y plus T2 in the y. They're both positive. Okay. And so then we also have minus, okay, we have minus 30 newtons. And that's all going to equal 0. Okay. So on this one, the x component, we could write that out again, right? So we could say T1 in the x, well, that's going to be T1 cosine 30 degrees. Okay. And then we can minus that from T2 cosine of 60 degrees. Okay. And actually, we'll set those equal to each other. I really didn't have to. Okay, nice. Now, we're going to, when you come here, you're going to realize we need to know either T1 or T2, okay? And we can get that from here. And so if let's add that to the other side. So we have T1 in the y plus T2 in the y, and that's going to equal 30 newtons. Where are we at time-wise? Okay. Let's just summarize what we've done so far, and then we'll come back to this question on the next video. So we want to figure out what T1 is as well as T2. They're both at an angle. So we have an x and y component to T1 as well as an x and y component to T2. So if I look at the sum of the forces in the x direction, that would be a positive T1 in the x minus T2 in the x, and those are the only forces in the x direction, and that's going to equal 0. Okay. If I want to, I can add that T2 to the other side, and so what I had written before, T1 in the x is equal to T2 in the x. Okay. And then I laid out what those were. T1 cosine 30 is the same thing as T1 in the x, and then T2 cosine 60, that's the same thing as T2 in the x. Okay. Now I looked at the sum of the forces in the y, and I said I have a positive T1 in the y in addition to a positive T2 in the y, and then I have a negative 30 newtons in the y, and that's all going to equal 0. And then I just added this to the other side. So that's where I ended there. Okay, so when we come back for the next video, we'll continue with this process and then take info from here and plug it in over there.